On this episode, Scott and I welcome our very own Nate Warfield, Eclipseiums Director of Threat Research and Intelligence, to the show today to discuss network device supply chain security. Stay tuned for this edition of Eclipseiums Below the Surface. This is a Security Weekly production for security professionals by security professionals. Please visit securityweekly.com/subscribe to subscribe to all the shows on our network. Well, welcome everyone to Below the Surface, the firmware and supply chain security podcast, done, of course, in partnership between Eclipseium and the Cyber Risk Alliance. It's episode number 13. Mr. Scott Shefferman is here with us. Scott, welcome.
Hey, man. Can't wait. This is always fun. I can't believe who we have as a guest today.
I know, right? We're back doing some new episodes and starting things off right with our guest today, Mr. Nate Warfield. He has 20 years of experience in network security and engineering, including designing networks for Microsoft and other Fortune 100 companies. During his career at Microsoft, he transitioned to security research and vulnerability management, managing researcher engagement and patch delivery for high-profile Windows vulnerabilities. A prolific conference speaker. I love that. He has presented his research on systemic flaws in cloud and network security at numerous conferences worldwide. In 2020, he was named one of Wired Magazine's Wired 25 for starting a volunteer group providing threat intelligence to hospitals and healthcare organizations during the COVID-19 pandemic. Nate, welcome to the show.
Hey, thanks for having me, Paul. It's good to be back.
Yes, we're always doing podcasts together. It seems like, which is great. But I want to talk today about. It's interesting. I've been talking to some of our collective peers about the security of. Some people call them network appliances. Some people call them network devices. I guess I'm kind of old school, right? I still call them appliances because appliances were the hot and shiny thing 20 years ago, right? You had a need and you went out and bought an appliance and it solved that problem for you. But I guess, Nate, start with identifying what we mean by network devices and network appliances in this context.
Yeah, so when I'm talking about network devices and appliances, I'm generally speaking about the stuff that you buy that you put in a server rack. So we're talking switches, routers, firewalls, load balancers, which now sometimes get called application delivery controllers. Anything that's basically in line in your network stack between the internet and your end user, or the internet and your business, right? Your website, your database server, stuff like that. I generally don't, when I talk network appliances, I'm generally not talking about like your home routers and your Wi-Fi access points and things like that. Although I guess in large businesses, some of the big like wireless access point concentrators, I would probably put those in the appliance category as well.
Yeah. So, and what we're talking about is folks with who still have physical infrastructure and are not all in on the cloud, which I'm learning is a lot of people. Everyone just didn't pick up and move everything to the cloud all at once, click their heels 3 times. Hey, look, we're in the cloud, right? There's still a lot of this gear.
Well, you make a good point too, because a lot of these vendors, I know that a lot of the appliance vendors like F5 Citrix, Barracuda, Fortinet, like the list goes on. Most of them have cloud VM versions that you can run. So they want to still capture that business of people that are going to the cloud but want their probably maybe you're a Fortinet shop and you want to keep doing it in the cloud along with your on-premise stuff. So most of these, I guess I would somewhat extend it and say that a lot of the same attack techniques and persistence techniques work on the cloud VM versions of the actual old school hardware appliances.
Yeah, no, that's a great point. And also, I think I talk with, again, like some of my peers. So this isn't like extensive research that I've done. In this particular scenario, it's a large organization. I won't even say what industry it's in, but you've got a large enterprise and they acquire another business and they happen to have some of these appliances that are there. It's a long process to get rid of those devices, or, I don't want to say get rid of, but you're sunsetting them, right? You're end of lifing their service. But they're providing a service to the business today, and that just doesn't happen overnight either. And a couple of people I spoke with are in exactly that scenario. They follow folks like Eclipseium and the security news and are like, oh, there's vulnerabilities, threat actors are going after these. Do I have any? And lo and behold, oh yeah, that business we acquired, they have some, and we still haven't, taken them out of service yet.
Yeah, and it can be hard to migrate off of those things too. I know when I was at Microsoft, we were F5 and a Citrix shop combined, as well as Cisco and Juniper. But you when you start to build, especially like in a large enterprise, if we're talking an enterprise that has the capital to go and buy other businesses, you'll end up with things that you design and you sort of built it around the hardware solution, right? There's some functionality and features that say like F5 has that. When you design your application, you're reliant on maybe their persistence mechanism or their failover mechanism or whatever it is that keeps your application or your business resilient. So trying to forklift, upgrade, and take out one technology and put in a different technology is a lot more difficult than just say, we're going to put a newer device in or upgrade the software or firmware on it.
Yeah. So we end up with a lot of these devices, whether on-prem or in the cloud, and what have you, and it tends to be problematic. I feel like, and this is a question for both Scott and Nate that I'd like to ask recently. I feel like threat actors, particularly who are conducting ransomware operations or involved in ransomware operations, are targeting these network devices. So two-part question. Do you find that to be true today? And secondly, why do you think that's the case?
It's go ahead, Scott.
No, I was just going to say I'll take the first part and let Nate have the second part.
Perfect.
Yeah. So on the question of like, are they the answer is absolutely yes, emphatically. It's in ransomware and nation state as well, hacktivists as well. We used to track that here a lot at Eclipseium when it first started really taking off 3 or 4 years ago. And we were curious what groups were doing what. And we just kind of almost at some point about a year ago threw up our hands and said, this spreadsheet is ridiculous. They're all hitting these devices almost ubiquitously as a matter of course and as a first preference, which I'll let Nate talk about. But by and large, it's just I don't know of a single ransomware actor of any weight or any importance that does not target these devices, and it's just become the most effective reason for them to, the most effective entry into an organization. I'll let Nate handle why that's the case because he's done so much research here, and even Nate, I'd say you've even pushed the boundary even further as to why they might want to enjoy the persistence and the presence and the positioning they have on these devices once they have them.
Yeah, thanks, Scott. They're definitely targeted. It seems to be becoming more common now. What's interesting is actually, you mentioned in my introduction, the CTI League, the group that we started during the pandemic, that was actually started. The impetus behind it was a Citrix vulnerability from 2019 that I had just done a conference talk in Tel Aviv right before the world shut down. And after the pandemic is starting, I realized there was a lot of these devices that were out there. I saw a thing of a hospital getting ransomware in Germany. And then I found my own medical facility in Washington that had 2 of these things. So that was sort of the like OMG moment of, wow, this is going to be a problem. And the draw or the sort of the attraction of these devices to actors, both ransomware and nation state, is that there's just not any visibility to traditional security tooling, right? There is no SentinelOne, there's no Defender for firewalls. So it's a good place to sort of set up shop. They are always going to be internet exposed at some level. The Citrix Vuln from 2019 was against their SSL VPN endpoint, which, as the world shifted to the work from home world that we all know and love, that is not something you can just take away from the internet. So by their very nature, it has to be exposed. And also, because these are infrastructure devices and mission critical, they become the lead time on patching them. It's not like a patch Tuesday where you say, hey, we're going to reboot the server tonight and it's going to be fine. It's more, this is a piece of networking gear. Our company is full remote. As soon as we take this down, the entire company is no longer able to work. And you sort of have to pray that everything goes right. The upgrade goes okay. There's no functionality changes that the vendor didn't tell you about. So the end result is these things end up staying unpatched longer than probably your standard Windows machine or your iPhone or what have you. And then, that's a perfect place to set up shop, right? Mandiant found a group that was attacking an unnamed couple of load balancer companies, and living for like 18 months persistence was average before anybody really realized that they were there.
It's interesting. I presented at BrewCon in like 2009 or like a long time ago, when I was doing, one of the points in my career, I was doing a lot of firmware security research. And the reasons that you list, Nate, for attackers wanting to attack these devices is like slides right out of that presentation that I was talking about. In this case, it was before we said IoT devices, it was embedded devices. Like, why would attackers want to go after these devices? It's exactly what you said. They're internet connected. No one really pays attention to the security on them, right? There's no monitor, mouse, and keyboard on them, or modern defenses that most workstations and servers have. They can use it as a jumping off point. The traffic flows through them. Like, all the reasons why attackers are going after them today, I was highlighting because I'm just enamored with firmware and devices like this, that's why attackers are going after them, right? And it turns out that it took a while for it to morph and change and become really popular. But that's exactly why.
I mean, one thing to think about too is I think there's a large amount of awareness already that attackers reuse credentials and go to access as service brokers. They purchase credentials for these devices, for those VPN connections, etc. But what a lot of folks don't realize is when you're doing incident response, if you're assuming they got in on the device because of credentials only, you might be missing the bigger picture and persistence. And sometimes those credentials are actually siphoned off the device after the device itself has been rooted at its OS level via these RCEs, the same kind that Nate's been researching so heavily. And I think people, unless you're like looking at this overtly every day as a researcher, I don't think people realize the amount of the volume of RCEs that have come out across pretty much every and any vendor you can name off for the major vendors. And these vulnerabilities have really long legs. They go for years or 2 or 3 or 4, or sometimes 10 years before these devices are patched. You can still use Shodan and find vulnerable devices with 3, 4, 5-year-old CVEs that are remote code execution CVEs. And so there's a marked difference between only having credentialed access to device and having root on the device or persistence that can survive a reboot, and then also the ability to configure that device at a device level with all the segmentation and some of the other services those devices ironically provide to the environment. So you have kind of omnipotence once you're there as an attacker at the root level.
So
and
go ahead,
to your point, Scott, these things are generally, when we want to say, let's say we look at a VPN device, that's going to be installed someplace that has pretty significant access to the network, right? It's if you're VPNing in and it's trying to look like you're at the office, you need to be able to access everything at the office. And then as far as, getting on the device and the difference between stealing user credentials or rooting the device, a lot of these things have a pretty nice set of tools on the device. It's like this most recent Citrix thing they have LDAP certs. They have the ability to talk to Active Directory controllers built into it, because at some point in it's some part of the component of the device will let you do Active Directory authentication for your VPN users. So it has to be able to talk to AD, generally using an open source tool. And once it's there, it's fairly easy to abuse said tool to either try to enumerate the domain controller or maybe dump lists or what have you.
And they're just using the service account that is on the network device as a foothold. That's what someone was telling me yesterday.
Yeah.
Which is, for an attacker, this is great. This is great. I got access to AD. Also their attackers are on a system that is typically not monitored at the same level as another Active Directory connected computer, as an example, right? Yeah. So what I speak with people and recommend is, if you're running Active Directory, the computers that are part of the domain, they should have something like sysmon that's doing process level logging, and you should aggregate that, and then you should threat hunt with that. You should have your SOC team monitoring, analyzing that. Except that works great, except for these network devices that we're talking about. So Nate, like, what's the logging level and visibility like? Is it pretty poor, like in practice, but also in capability? Is it both?
Yeah, so I mean, you keep in mind that most of these systems are going to be Linux or BSD based, so they're going to be using like syslog-ng. The logging that's built into these devices is generally it's device logging of error messages or
Yes.
this interface went up or down, this resource behind the servers failed a health check and it was marked down.
I find that with like my pfSense logs, right? Like it's logs about what the device is doing, not the user level activity that's happening in the operating system.
Exactly. So it may, and a lot of these do have some ability to do AAA logging, but you have to set it up and say, okay, I'm going to send remote syslogs to my system, my server to log AAA stuff of people logging in, getting their whatever roles assigned. But there's nothing like when you mentioned having endpoints and running sysmon. Like, if somebody gets onto my Windows domain connected computer and all of a sudden starts running a bunch of weird DC querying commands and trying to dump the SAM or trying to, enumerate or use some tools like Bloodhound, that's stuff that can be picked up by an EDR solution, right? Just say, hey, Nate should never be trying to dump the password database off the domain controller. That's not normal.
Right.
Let's go investigate. That's not something that you'll see. You might see, maybe your domain controller sees, hey, the VPN device just tried to pull the SAM down. Is that a problem? I don't know. Like that's when it's the VPN concentrator, that might be something that an admin or an investigator would think, oh, this is totally normal. That thing needs it because it does Active Directory off.
Yeah. Plus, when you have persistence there at system level, I mean, you can do anything you want to those logs. So you can lie, right? I mean, you can erase, you can backtrack, you can do all the things that you would do to cover your tracks.
Yeah.
Yeah, and I think also that speaks to the persistence that you have on them as well. Now, Nate, I like your techniques for persistence better than what I've seen in the wild. Now, I don't want to give attackers ideas, but one of the threads that I've been, or kind of trains of thought I've had is how attackers acquire and develop their TTPs, right? And I think most oftentimes they're looking largely at what we're doing in the security research field and basing it off of that. And you had presented on some research, I think last year, that talked about a way to persist on some of these devices. And I actually edited that blog post, is how I consume this information. And I thought it was awesome. But have you seen attackers doing that? So I guess first describe at a high level, what your research was, and then we'll talk about how it plays into practice.
Sure. So what I did last year was I decided I want to do a sort of an offensive versus a defensive talk, and I used the F5 exploit that came out in May of 2022 as sort of my my proof of code, my proof of concept. Since I'm not an exploit dev, I just like to do evil things. So what I figured out was, at least with F5 and with Citrix, I was able to use an off-the-shelf open source C2 framework called Sliver. I was able to, use this exploit to get onto the device, get it to basically drop sort of a loader script into a config directory where all of the, your SSL certs, your keys, your load balancer configs live. And then add some essentially commands that would run this script if the device was rebooted, if it changed failover state, if certain log messages were fired. I could have it basically execute this script that would go check for the implants. If it wasn't running, it would start it. If it wasn't there, it would download it and then start it. But the beauty of this was that because I was hiding the loader script, which was just a few K inside the config directory, if say you got your load balancer got hacked. You go and you say, okay, there's somebody here, they're breached. We're going to do a config backup. We're going to wipe the device, maybe even put a new drive in it. Then we're going to just restore it from our config backup and turn it back on. Well, there is some level of assumption that the device can talk to the internet, but that's tangential. As soon as you put this thing back on, the script would kick back in and it would go and say, okay, you just patched it. It's no longer vulnerable. But as soon as you put the script on, the malware is going to come back. And to your question of have I seen anybody doing this? Yes and no. I haven't seen anybody yet using open source C2 frameworks in network device attacks like you see some of the generic web shells. And this latest Citrix campaign, people were using a lot of just kind of crappy PHP web shells to get in. nobody was actually dropping C2 binaries that were open source stuff. But what I did see, and I did notice when I was reading this a blog about the Barracuda gateway attacks that were happening, the attackers actually they modified the config of the Barracuda, and they put in, and I don't know the details because I don't have one to play with, but they modified the configuration of the Barracuda device so that if you did the same thing, you said, okay, because Barracuda was telling people, hey, just, if you've been hacked on this hardware chassis platform, just send us the device, we'll replace the whole thing. So of course, if you're RMAing a device, you're going to take a config backup, swap the device out, put the config backup back on. The attackers, I can't necessarily say that they copied me, but they used a similar thing of let's backdoor the config of the device in a very small way that still allows us to get persistent access if it's wiped and reinstalled. So a little bit of pride for me, maybe not pride.
Yeah.
So, Paul, do you remember the medical white paper that we've been authoring for quite some time? It's going to be out hopefully soon. But that was originally based off kind of the impetus for it was the pulse secure devices and that CVE that ends in 11510. And that CVE was interesting because when that campaign hit, and I believe that was a China PRC Nexus campaign originally, people like the Barracuda thing that Nate just mentioned, you had to send your device back to Pulse Secure for forensic analysis or replacement or repair, and send it back to you. And it was extremely disruptive because Pulse Secure are, pretty expensive boxes that handle a lot of bandwidth and larger environments and larger type of customer use cases. And it was weeks and weeks because they were backlogged as a vendor and being able to actually respond and get devices back to folks. And part of the problem was you couldn't do that in the field because of the same problem. You had this notion that there is no ability for the end user, the customer, to know whether you could rid the device of the actor. And that presents a lot of problems because these are, like we said earlier, edge devices that are highly functional. And ironically or non-ironically, depending on what color hat you're wearing when you say it, they're also a security control unto themselves, right? So you're losing a primary security control in the form of like encrypted tunnels and remote access and remote workforce and applications that rely on that connectivity for uptime. Like it was the hospitals that were impacted, other government organizations, agencies that were impacted. It was tremendous impact. So when we did that white paper, that was one of the things we wanted to bring to the forefront was you can't just think of the device as a wipe and restore kind of DRP scenario with your playbooks and your incident response playbooks. You have to think of it as like, this could cause significant downtime. And for a hospital, that was unacceptable. And oh, by the way, in the same research, we're like, okay, if I can get to the Pulse Secure box, what if I can get to a Windows box that has the medical records? And what if I can implant the UEFI from the internet going through the Pulse Secure box? And we showed a demo where you could do that. And we're like, this is really bad. I could go from the internet to an RCE on an edge device and implant a medical records device at the UFI level. That's a big problem, right? So I think the world isn't ready to understand these things yet because it's just too scary to actually even absorb, but it's the case.
I think there's been a lot of instances over time. Like I don't think any of this is necessarily new, right? I mean, we could probably go back and research and go, yes, attackers are going to go after the persistent method that hits the operational aspect of like your sysadmins, right? Because most of us have been sysadmins at some point for something, and now I'm kind of worried now because when I approach a firewall or any of these network devices, my first thing is before I do anything, I make a config backup, right? Then I'll go apply my upgrades or wipe the device and start over, but I have my config backups because that's where all of my rules and all that configuration that I work so hard that would be very difficult to recreate lives. And that's standard operating procedure for over 20 years. I mean, you could go back to the dawn of computing, right? We like to make backups and do what we need to do and then restore our backups. That's a great place for attackers to hide in this scenario without having to go. I mean, there's other ways they can persist like UEFI, as Scott points out, but hiding in that config backup is perfect. I think it's a great place for attackers to hide. But also flipping to the defensive side, how do we detect that? How do we detect that something in the configuration is reinfecting. Do we look at the config, or do we need different methods?
I mean, it's tricky, right? Because like I mean, my forte with F5 is a little bit cheating because I worked there for a decade. So when I started doing that research, in the back of my mind, I was like, yeah, I know a couple of tricks already. But they were largely undocumented functionality that had been added at some point over time that was still there that allowed you to just say, okay, I want to execute a command when a thing happens. I don't know that there's a good way for people to understand that. It's sort of, you if you're not an expert with the thing, if you're not an expert with that specific device, which the F5 one was easy. Citrix actually took me twice as long as F5 because I'm not as good with it, but I still managed to figure it out. But I had nothing but time, right? I'm not in an incident. This is not one of 300 things that I need to look at while I'm trying to figure out how did they get in. So, in an incident response or defensive standpoint, there's a lot of intrinsic knowledge that has to sort of be expected of people to catch these attacks. That attackers or people like me have nothing but time to sit and think like, how evil can I be? How deeply can I burrow in this? And I haven't even touched on some of my supply chain concerns for these devices because I know you're going to get to that, Paul.
Yeah, no, absolutely.
My mind was going the same way.
Well, yeah, because I think it's interesting that as attackers, we can affect change in the config, and that's a place that is supposed to change. When we think of firmware integrity, as we do spend a lot of time here at Eclipsium thinking about that and putting it into practice and checking that, that's where there's areas of the firmware that really shouldn't change. And if they do, it could mean that it's been tampered with. Here, the tampering is in an area that you're supposed to tamper with. I mean, that's the config that's unique to everything and supposed to change. So I thought that was another interesting aspect.
Yeah, it makes defensive. I mean, even as we work on a defensive strategy for this, I have spent more time than I want to admit trying to figure out how do I, like, with a high degree of accuracy, detect somebody doing what I'm doing. Because literally my boss after my talk last year was like, that was a really cool talk. Now I need you to build a system that catches you, which was far more difficult than doing the talk, as it turns out.
Yeah. So let's flip to recommendations. How do we've established that these attacks are happening today, that they're pretty stealthy, in a very high privileged area, if you will, inside the network. So what can we do?
So the one aspect, the one thing that I think that would probably be helpful is for people to be able to. You should be snapshotting configs. As I was doing that research, the reason I ended up writing a loader script was because for example, the Sliver implant was 12 megs, and your standard config backup for an F5 or a Citrix is maybe a couple hundred K of gzipped data. But my realization was if I was doing config backups every night, like I used to do at a large Redmond software company, I would notice if all of a sudden, I've got 6 months of backups from my load balancer, and all of a sudden one of them is 15 megs and all the rest are 8 meg or 800K. That's going to stick out. But beyond that, even catching the scripting method, if you're snapshotting your config every night or hopefully on a regular basis, if you get breached, that's the type of thing where, you're going to have to go to something like, diff and, command line tools, but you could say, okay, let's, we know that the incident happened on this day. Let's go back a week before, 2 weeks before. Let's start diffing out the configs and see, did anything change? And yeah, there may be changes, but when it comes to like network devices and especially load balancers and like SSL VPN terminators and all these other things, the configs don't change that much. Most people set them up. They're like, okay, it's working. Don't touch it. As long as you don't touch it, nothing will break. So, if you go in and say, wow, there's a whole bunch of different changes that happen in a span of like 3 days, either you're doing some sort of change management where I say, hey, did anybody touch the F5 in the last week? No. Okay, well, now you've got something to drill in on and say, okay, well, why did this config change when nobody should have touched it, right? But short of that, there's not much way unless, like I said, unless you're an expert of every device you've got and you can read through every piece of the config and say, oh, okay, I found the one bad line out of the 6,000 in these config files. That's, it's not an easy problem to solve.
Yeah, and it's going to differ depending on which platform, which device you're on. And I should state we're not picking on any one manufacturer, right? I mean, we're just we're stating where the vulnerabilities have been disclosed and where the attackers have been, and where the research has taken place. It's not a knock on any manufacturer. I think across the board, I mean, they've been producing patches and paying attention to the problem. Certainly,
Oh.
the response I think has been fair. Would you agree?
I'd say it's a
I'll
knock
take
on
the
all
counter
of them.
side of that.
Wait, sorry,
Oh.
Nate.
I said,
Yeah,
I'd
go
say
ahead.
it's a knock on all of them.
Yeah, it could be.
Yeah, okay. So Nate and I might have thanks for the bump set spike, Paul, but I'll take the opposite side too, and I'll ask Nate a philosophical question, or both of you a philosophical question: is it too much for us to ask or to assume that there is a secure way to develop the code that goes on these appliances that are internet facing? Is this a physics complexity problem for which humanity actually can't solve for over time, as we pass through time and vulnerabilities and research is done? Is there no way to actually securely code these devices over time? Or is there a fundamental problem with basic things like an SDLC that puts in active testing and static testing before shipping code properly? Like, is it just like dev shop problems that we have at the software layer happening on these devices, or is it more of a physics problem that we probably won't solve for easily, even with the best intentions and all the resources in the world?
I don't think it's a physics problem, right? Like back in my sysadmin days, I was a big OpenBSD fan, and I actually managed to save my first startup from the antivirus and a couple of the other ones by using OpenBSD as my gateways. And OpenBSD, while there have been a couple of hacks or a couple of vulnerabilities, like it's by and large the most secure operating system you can plug into the internet. The difference is that OpenBSD is not something that's driven by Wall Street, right? And it's not driven by revenue. And I think that one of the problems is that when you become revenue driven, like the appliance companies, there's going to be the thing of, hey, we need to get this to market because Wall Street, the analysts are expecting it, or hey, we didn't have time to test this, but our customers are clamoring for this functionality. There's also the issues we see with some of the vendors, like, some vendors are very easy to look at their firmware. It's very easy to get around. There's a full shell on their device. Some of we've mentioned Pulse Secure, we've mentioned Barracuda and Fortinet, and a few other ones where their design decisions, and I'll just call them decisions, were to make accessing the file system and anything outside of their little restricted shell, they make it difficult, if not impossible. So that becomes that makes it us in the research world, it makes it a lot harder for us to do anything, because it's not something we can just get on and fiddle with. However, that hasn't stopped the Chinese from, for example, Fortinet has had a lot of issues with Chinese actors lately that are, they're probably just buying devices off eBay, or they're acquiring them and spending the time and effort to find zero-day vulns in them. But we, as the research community, we don't either have that much time or the financial motivation to do that.
Yeah, I think security through obscurity is kind of the model that you're referencing here, Nate, and that it doesn't work for, in this case, network device manufacturers, right? If there's going to be bugs there, someone's going to find them. Just because you make it harder to access doesn't absolve you of writing more secure code, producing better patches. And look, no one writes software, perfectly secure the first time every single time. To Scott's point, it does take effort, and maybe there could be more effort put into making it more difficult for attackers. I'll agree with you there, right? So we have that. We have that issue.
So here's another philosophical conundrum that I've been thinking about my whole career, and a lot when I was supporting the Navy, because I did a lot of the vulnerability management. And one of the cases I had to make at one point in the Navy after some Iranians did some bad things was that there's, at the end of the day, if we're just being super honest with ourselves as practitioners in this industry, the difference between an implant or a backdoor that is there intentionally and an RCE vulnerability that is at some point, quote unquote, discovered by a researcher or a threat actor, at the end of the day, when it comes to raw risk, there's not much difference between intentionally putting a backdoor there or accidentally putting a backdoor there. Because the other truth is that we over here don't know truly whether some of these RCEs are there on purpose or not. We can talk about the chip wars. We could talk about supply chain threats that come from the supply chain. We could talk about threat actors like ransomware actors that hit companies like MSI and AMI and the other research that we're all familiar with, probably, that, in affect maybe the development environment or the staging environment and implant firmware updates that are malicious on purpose. But even if you don't know any of that, when it comes to like assessing risk, you may as well assume that these things are there on purpose or that they're not, because it doesn't make a difference. At the end of the day, the risk is the risk. That RCE vulnerability is a root level, system level backdoor from the internet for these devices. And it should be treated with the same amount of urgency, and the impacts are just as grave when they're exploited in the wild and the impacts manifest, the risk actually manifests. So I feel like it doesn't do a whole lot of good to talk about backdoors and implants that are intentionally there versus RCDEs that are coming out at such a high rate. And a lot of these are chained. Like when I remember the Eclipseium FTA attacks, that was a chained, two-stage vuln. The first one got you to an attack surface that allowed you to then get root on the device. And you're like, and when the researchers analyzed that, they noticed themselves that if I were an attacker, I would actually have to know pretty well how that operating system and how that architecture was constructed for me to know how to chain those two together. And it was almost, they were indirectly saying that somebody who discovered those vulnerabilities had some intimate knowledge with how the Eclipseium boxes were created. I took that at face value. Again, we don't get to know the truth of the matter. But at the end of the day, it's awfully sus how many RCEs are coming out and how grave they are. Like the level of access these vulnerabilities give people is just phenomenal.
Well, and it underscores the supply chain problem as well. And I think in this case of a network device, you're purchasing this device and you almost have to have a higher level of trust because you're purchasing the device. You're not building a computer yourself and using open source software and being intimately familiar with all the hardware and software on that system and going, that's what's going to do my VPN, for example, right? That's, for most organizations, that's too much responsibility, too much work to take on yourself. So we're going up the trust chain and going, I want to buy a device, but now I got to trust the supply chain a lot more than if I were going to do it myself, to your OpenBSD example, Nate, right? So when you get an appliance from a vendor, you got more of a supply chain problem because you're trusting the supply chain even more in that scenario.
Yeah, and what's interesting, like Scott points out, some of these vulnerabilities are very complex, and that's true. In fact, this latest Citrix one was fairly complicated in that the Rapid7 exploit had to be tuned for per version of whatever Netscaler that you're on. The flip side of that, however, and I was candid, let's say, with my opinions on this and my load balancer talk. The Citrix vuln from 2019, and then there was an F5 vuln from 2020, they're basically the same exact vulnerability, and it was a past reversal thing. Now, the part where I really sort of held everybody to task was that the Sky Orange Psy had talked about this at Black Hat in 2018. And in his Black Hat slides, there's quite literally a slide that has the ... semicolon / like the thing that was used in both of these attacks. So it was interesting to see that, a year and a half-ish after he talks about it, someone finds it in Citrix. And then, that was December 2019, June of 2020, F5 has essentially the same vulnerability. And then if we fast forward to the one that I used in 2022, the F5 one, that was basically they were using a HTTP host header in a request to essentially be authorization. So if you spoof the header and said, hey, I'm coming from localhost, the call is coming from inside the house, then it would let you go in and run administrative commands. We here at Eclipseium just found a similar vulnerability in Megarack VMC, which was, they were doing the same thing. Granted, it was a hard-coded IP in the firmware, but we were able to say, hey, if we spoof the request and say that it's coming from the device itself, it's like, cool, you're already here. It'll just let the thing work. But so there's
Is that let's be super, super honest. You're a dev. And you've done that, and you're implicitly trusting that header to do something it's not even supposed to do from a trust auth perspective. You're designing your auth system fundamentally incorrectly. Even if you can design it that way, it doesn't mean that's the right way to do things. So is that a backdoor, or is that an ignorant developer at the design phase? What is this thing that we are seeing? Because
it could be either.
It's a really bad bone.
It really could be either, and I think of some of the very similar ones in the IoT space that have happened this way that developers put in, and I think either it's put there intentionally, right? But in a lot of cases, I also see the other side, Scott, where it's the developer just didn't threat model it. The developer was like, I need this process to be able to access the back end, and I can't authenticate the process, so I'm just going to give this process a way to access the back end and host header or user agent or whatever it is, not thinking that, an external threat actor can come in and do the same thing. So I think it's both.
I'm talking about the larger companies, though. Like these companies protect all of our critical infrastructure, all of our financial infrastructure, our medical infrastructure, our power grids, all of the Fortune 500's production environments. They make a lot of money, and they're selling the most important device to those organizations that they have, other than maybe a few other critical devices in their OT environments. So with that in mind, is Jen Easterly correct in saying that we should expect a securely designed, securely configured device when we take delivery of it as the federal government? Is that a fair request?
I mean, let me back up just a second. When it comes to the developer doing this way, I don't look at that as a backdoor. To me, that is sort of that's hacking, right? We as hackers, we find ways to use systems that they weren't designed to be used, and that's how we get to do things that most people don't do. I don't think that whatever developer said, hey, I'm going to trust a host header, or hey, I didn't think that maybe someone would send a request with a ... / because that's not RFC compliant. They're not thinking about it. They're thinking in a sense of, I need to build this feature. I need to get it to work. I have a deadline. Let me do it this way. And then the problem becomes when we've got these network device vendors that have been around for 2 or 3 decades. Some of this code is just baked. They're like, yeah, we know this part works. We don't need to touch it unless there's a bug. But do they go back and do security reviews, right? Maybe not.
Isn't that what fuzzers are for? In a modern development environment, in the current, isn't that what dynamic testing for and third-party pen testing is for?
Yeah, but
I feel like vendors are relying on bug bounty programs to do their job.
But nothing's going to be delivered to you as the consumer. A consumer is kind of a bad word, but in enterprise or whoever is acquiring technology, you have to run on the assumption that nothing's being delivered to you perfectly securely. Yeah, I mean, if it were, we would all have to go find new careers, right? We wouldn't need people like us if that was the case. I don't think that's ever going to be the case. I mean, all software has bugs to different and varying levels and degrees, but things aren't going to be delivered in a perfectly secure manner. Now, sure, we can raise the bar of what the default means, but we're going to fight that balance of usability and security, right? Microsoft could deliver. I'm just going to use Microsoft as an example. I'm not knocking them, right? In fact, I'm actually siding with them. They could deliver a way more secure by default operating system, but nothing would work. If you push that to the extreme, they could deliver a pretty unusable operating system. It would be awesome at security. It would be pretty unusable, right? I mean, Nate, you've worked at Microsoft. I mean, you've lived this battle at your time there. And I've spoken with people from Microsoft, and I empathize with them. I'm like, you've got a lot of customers, very critical, to your point, Scott. A lot of these vendors are providing technology to very critical areas to very critical companies, but you still got to balance that usability and security.
Yeah, and the thing too, right?
I don't feel like this is about usability. I hear your point, and you're right on, especially on the assumption that nobody should assume that the thing they take delivery of that's closed source or is designed securely, including the iPhone sitting right in front of me. But at the same time, I feel like if Nate can find a bug, if Vlad, our researcher, can spend 6 minutes and write an exploit to put a BMC into a permanent reset mode that the data center can't recover from, then the companies that are building these devices should be able to resource and hire internal folks to break them before shipping code. Despite the economic parameters that Nate mentioned correctly, there's a lot of rush to get features out in a competitive environment. But at some point, the consumer base and the government regulatory base needs to make an economic stick instead of just the carrot that we have to produce features at high feature velocity. And you have to make that stick big enough to slow down feature velocity and dev velocity in order to fuzz and internally and hire third parties to break your stuff before you ship the code.
What I hear you saying, Scott, is that
happen, we're going to have this conversation 50 years from now, if we're still alive.
But what I hear you saying is we can do better, and I agree. Like the bar can be high. The bar can be high.
The challenge. I'll throw.
I feel like we're at that precipice, that threshold of critical mass, where we have to step back as a whole society and say we are literally doing this completely wrong. And it's not benefiting us to have faster feature velocity or more features right now. It's actually hurting our economic productivity, our ability to make decisions, our trust in critical infrastructure, our economic stability. All of these things are actually at that critical mass where we have to step back and say we have to do it right, because there actually is, to your point, Paul, a better way. We do know how to do this today already. So I asked the question whether it was a physics problem. You guys said no. I totally agree with you. I'm glad you guys both agree that we can do this better as an industry. I get so spun up these days because there are so many people pulling their hair out 24/7 over these damn bugs that could be fixed before code ships.
So I want to point out, I want to throw out a thing, because we talk about, we're kind of harping on this whole rush to get features.
You're on mute, buddy.
There is a problem. There is. I think that we see the feature rush problem manifesting more these days with like Azure as a cloud, the things that live above the hypervisor layer in Azure, right? We're seeing a lot of these vulns coming out where we as security practitioners are like, oh my gosh, how could you do that? Why did you make that design decision? Which that is where having, and Microsoft, one of the things that they did a good job with, right, is that, okay, everybody has their things with Windows. Oh, there's all these problems. When I worked for them in the research or MSRC, like my friend Alex Ionescu and James Forshaw from Project Zero, we used to have these discussions, which is that why do the bugs that James and Alex send in, why aren't they fixed? And the reason behind that is, in talking with like the Windows development group, they're like, those bugs are in code that have been here since Windows NT 4. Like fixing that stuff you're talking about re-architecting something that is 25, 30 years of code. The risk of stability to fix that is huge. Now, if we look at a different part of Windows, which was HyperV, HyperV was designed from the get-go to be as secure as possible. I think there are 6 researchers in the world that I know personally that can break HyperV, and 2 of them work for Microsoft. The rest that didn't, I would drop $300,000 at a time on a HyperV RCE. But that has been designed securely from the beginning. And I used to be in meetings with the HyperV dev team. They would say, hey, we've got a feature. The security team would say, no, we broke it. They'd be like, okay, we'll just push that to the next version. They wouldn't rush the feature out. Instead, they said, we're never going to release this without the security team signing off on it. That is the right way to do it. And what we've seen in Windows, when you see some of these things, these people talk about, oh yeah, you've got these special application containers and these different things that protected mode browsing or protected, whatever sandbox browsing in Edge and things for Office. Those are all using the same Hyper-V container design under the hood. That's what they're using. They said they figured out a way to containerize and make it secure, and now they're reusing that technology. But there are some things, like I think yesterday there was a vulnerability in Patch Tuesday. There was another NTLM hash disclosure. Like how old is NTLM? Yeah. They can't take it out. They can't get rid of it because it will break so many organizations that have relied on it for decades.
Nate, I want to go back to network devices for a moment and talk about what hits like your day to day. And that's what we do here at Eclipseium to help our customers with these issues. And I think ENDS plays a role, and there's been a lot of work since I've been here, certainly expanding our capabilities and coverage for discovering vulnerabilities and even tampering with network devices.
Yeah. Okay. So where do you want to talk about?
Oh, just like in general, like what we do to help customers with, identify these problems and remediate.
Yeah. So, I mean, first and foremost, we don't do, I wish I had the team to do vuln research against these, but I just don't. So for now, mostly a lot of what we're doing is somewhat reactive. So we say, okay, we know that there's vulnerabilities in these devices. Our platform can, tell an administrator, hey, you've got this fleet of devices. These are the vulnerabilities that they're susceptible to. Like I said, I've been working heavily most of this year on a way to essentially do firmware integrity attestation. So knowing that your Cisco or your Juniper or your Citrix, it's none of the binaries have been tampered with, right? We saw Fortinet people where they were dropping like backdoored binaries of system binaries. The idea is we want to be able to detect that. That level of stuff, being able to do things like processing YAR rules against logging, basically doing a lot of what you would do as a DFIR or incident response process. We want to be able to do somewhat of that stuff just in real time all the time, right? So if all of a sudden your NetScaler has a weird PHP file show up in the web path, you get an alert like saying, "Hey, this PHP file showed up. Did you do this?" Because a lot of it is that they just don't know. Right. And we've talked earlier, there's no EDR, there's no real, there's no CrowdStrike for NetScalers. So, if without knowing something weird happened, that's how these attackers last so long. So the idea that we're trying to do is build essentially sensor capabilities to tell you if anything's changed. Eventually, I'm sure my ML nerd friends will figure out a way to look at configuration changes and say, yeah, this is probably malicious.
And we do. There is something in there about a malicious firewall configuration. Is that true?
Yeah. We've got a couple ones. We did one where malicious firewall rules, like people opening up any rules, people adding forwarding rules. We're detecting specific payloads for the NetScaler, the latest NetScaler attacks. So it's getting there. We have tons of work to do, but we're making a lot of progress at it.
And what I like is we're addressing like a really pressing problem, right? Like there are threat actors actively going after these vulnerabilities, and we're helping people to discover these issues and mitigate, because this is happening now.
Yeah, and there's some cases too where we can literally pull the binary itself from the OS and inspect it on certain Cisco devices, etc. And some customers have certain devices they really care about. They give us authentication. We can actually do some really cool trick stuff at a lower level, much like we do on x86 platforms too. So that's part of what it takes to find changes of integrity of these binaries.
Yeah, and we haven't even gotten to what the world that I see ahead is more tampering than people expect. For example, Citrix, they package all their VPN client installers in their firmware images. I'm expecting that within the next year or two, we're going to see somebody get into a network device. They're going to backdoor the VPN clients for the end users, and they're going to tell them they're going to just push it out and have it auto update.
Yeah.
How would you know?
Right. Yeah, you give attackers a lot of great ideas.
Yeah, I know. I'm good at that. Hopefully fixing them will buy me a nice house someday.
Well, and but if we don't talk about that stuff, people may not know that that's a potential threat vector. And so, what we do, I think, is important. We'd run that. Is that same thing we've been talking about in security since the dawn of time. If we talk about the attacks, the attackers may start doing them, but we're also arming the defenders with the threat vector so that they can defend our infrastructure as well.
Yeah, it's just who gets there first, right? Us or them.
Right. Well, awesome. Scott, Nate, anything else on this topic that you wanted to share?
I just wanted to say we are so lucky to have someone like Nate on our research team with all of his experience and everything he's been bringing to the product and to the team, to the research. We got guys like Richard Johnson joining, and it's just becoming one of the absolute coolest places I've ever worked, with some of the brightest minds breaking stuff. So that's all I wanted to say, and I appreciate Nate, taking the time to come on today.
Yeah, Nate, thank you.
You're too kind, Scott. You're too kind, Paul.
I am very appreciative of the team here. I'm just lucky to work with all these amazing people. Like Scott mentioned, a couple of names, but our research team is a pleasure to work with, and just unbelievable, vast amounts of knowledge there that's going into our research here at Eclipseium. We'll be hearing more about that on future episodes for sure. So.
Yeah,
awesome.
I really enjoy the team that we've got. We have a nice mix of skill sets that all complement each other. And there's honestly, people ask me what I do for a living, and I'm like, well, the easy way to say is I basically have my dream job. I just get to break things and be evil all day long, and then I'll try to figure out how to fix it. And I have to give a shout out. You said you mentioned BrewCon. Well, I'm heading there at the end of the month to go talk about firmware hacking and how to use open source tools to find vulns in firmware. So that'll be fun. I'll say hi to Tom and the crew for you.
Fantastic. Awesome. Nate Scott, thank you very much. That will conclude this edition of Below the Surface. We'll see you next time.